So just to introduce myself, in case you're not aware, I'm Terry Sweetser from APNIC, headquartered in Brisbane. You're probably well aware of who APNIC is by now. I have a few erstwhile assistants here from the Philippines and back from Brisbane. So you'll find while we'll be monitoring Zoom for questions. Of course, when we do have Q&A, I'll ask you to step up to either mic, state your name and your affiliation. That way we have it on the record. And just be advised, we are recording and we are streaming on YouTube as well. So the topic today is segment routing over IPv6. We have three speakers. Our first speaker is Aditya from Juniper Networks, and he's talking about the hype. Thank you, Aditya.
Thanks, Terry. So good morning, everyone. My name is Aditya, and I'm Principal Solution Architect for Juniper Professional Services in APAC. And it feels awesome to be back in person. It's been a long time, I guess. So today, the topic is SRv6 beyond the hype. And I think there's been a lot of collateral on segment routing in general. But recently, we have seen a lot of content and a lot of deployments happening on SRv6. However, I would perhaps focus more or less on the deployment experience and the challenges we have kind of faced deploying this new technology. So we'll talk about that. So from agenda perspective, just an industry outlook on SRv6 and also a case study, which is for Axiata in Indonesia. And from the deployment perspective, what were our experiences and challenges? All right. So if you see from scale perspective, or essentially from a 5G and beyond, first of all, why do we require segment routing in general? Because we have been using MPLS for such a long time, and things just work. But essentially, when we are looking at 5G, it brings a huge amount of scale where we have seen very large transport networks, perhaps, maybe more than 100K in certain countries, especially in APAC. The network essentially doesn't scale. So from that perspective, we needed to rethink in terms of the whole architecture piece. And it's perhaps not only for 5G, but also essentially for some of the large networks we have seen using unified or seamless MPLS. Now, in terms of 5G, it also brings a lot of use cases in terms of private 5G, where perhaps the service providers also have an extension into the enterprise, which could potentially be a manufacturing site. So it brings in its own challenge of managing these networks. So from that perspective, segment routing simplifies the network architecture in terms of putting the state in the packet rather than the network. So for example, for inter-domain routing, we used to rely on BGP to basically glue the entire network, because the state for example, in service of edge or core, potentially was not capable enough to, carry the RSVPT control messages. So perhaps one of the reasons for segmentation of this network using BGP as the transport plane was used. Now, segment routing essentially simplifies that. Also, in terms of new service differentiation, like network slicing, these are services which are essential for 5G applications, and segment routing actually has use cases or applications like FlexAlgo, which can deliver these services. Also, brownfield migration. So I think this is the most important aspect when we talk about technology transition, how simple or how easy is to transition. Obviously, it's not simple, but essentially, do we have tools? Do we have automation to help us transition from the earlier technology like MPLS to segment routing? So perhaps the main concern with our customers essentially is how to choose between the two different segment routing variants. So within segment routing, we have two variants. One is SR-MPLS and the other is SRv6. And it's very important that customers actually think through this, what makes sense for each and every individual, network. For example, we have seen customers who have typical deployments wireline in nature, core edge, or perhaps metro, and they are pretty much invested in MPLS as a technology, and it delivers whatever use cases they have. And from a future scale perspective, perhaps scale is not essentially a criteria for them. Then I would say, most of these service providers actually deploy SR-MPLS. Now, in terms of SR-MPLS, also we have two flavors. We have IPv4 based and IPv6. And essentially what we are trying to not push, but essentially suggest our customers is to move towards SR-MPLS for IPv6. However, having said that, there are challenges in terms of legacy gear, which perhaps doesn't support that. So, SR-MPLS IPv4 actually just works for them. The other flavor, IPv6, is essentially to make sure that, your future scale is considered as part of your transition. Now, SPs, service providers who want to migrate away from MPLS as a technology, they are typically 5G backhaul customers or cloud native data centers or customers who have massive scale, objectives to reach massive scale. For example, some of the customers in China and India have massive scale requirements. So potentially they would want to hop onto the SRv6 variant, which provides them scale and inherently is IPv6 in nature. There are other customers who have IPv6 deployments. Perhaps it makes more sense for them to adopt SRv6 rather than SR-MPLS. So from segment routing perspective, each category has a freedom of choice. Now, it also depends on what your objectives are, what tools you have. It's very important to keep the tool aspect or the operations aspect in mind when you're choosing a particular variant. And also skills enablement. So this is a flow chart kind of a thing which we kind of work with our customers, and we just came up with this. So what would make sense? If some of the devices support MPLS and the objective is to have lower scale, for example, service provider networks or ISP networks, which are transit in nature, we have seen that scale is not that big a concern in terms of number of nodes. And they want an easy button. So for migration or transition to segment routing, perhaps SR-MPLS makes more sense, whether it's IPv4 or IPv6 in nature. For higher scale 5G use cases, cloud data centers, SRv6 makes more sense. And given the fact that you are vested in automation and tools when we talk about SRv6. If you have IPv6 capable infrastructure, but would require scale and traffic engineering, I guess there are two choices we have. If bandwidth overhead is a main constraint, you could potentially use compression, which has been validated at ITF working group, and CSID has been adopted as the compression technology. Or for some customers, we have seen bandwidth overhead in certain use cases is not really a constraint, and flex algo could potentially be one viable choice. The other aspect could potentially be to aggregate your network using multi-instance ISIs and just use locator summaries to achieve end-to-end traffic flows. If there is IPv4 services, and one unique way wherein SRv6 kind of stitches up the network is by advertising IPv4 services with IPv6 locator next stops. It uses RFC 5549, which is extended next stop. and also a unique business as usual, so that there is minimal disruption, given the fact that any migration would certainly take some time. So we have MPLS to SRv6 interworking, and this is one critical factor for you to plan your transitions. So what's all the hype about? It's been, there are operational benefits, in terms of simplicity. Obviously, the technology is stateless. It is programmable. However, from operation perspective, the biggest advantage I see is BGP-free transport plane. When we talked about segment routing or SR-MPLS or seamless MPLS, BGP essentially played a major role in terms of transport using as a RFC 3107 transport technology. With SRv6, actually, we just do not require that anymore. So that's a big, big advantage, given the fact that, some of the state, even though it's in the BGP, you need to run that on the routers which are acting as ASPRs or demarcation points. With high availability, obviously, TILFA helps do that. So you have a single protocol. With segment routing, you don't need to run multiple protocols, whether you're running OSPF or ISIS, because this is SRv6. So I'd put more focus on ISIS because OSPF v3 is still not standardized. So TILFA actually provides you all the link node protection. Also, one unique way we can load balance ECMP traffic using flow tables. As I said, the biggest advantage with SRv6 is essentially scalability and efficiency. And MPLS inherently cannot provide that scale for one reason. When we say, cannot provide that scale, is essentially for the fact that you need a /32 end-to-end reachability. Whether you use BGP, whether you use RSVP or LDP, but for MPLS LSP to exist or FEC to exist, you need that /32 end-to-end reachability. With SRv6 summarization, we've just gone back to the earlier days of internet, where you could do longest prefix match, and you potentially could aggregate certain networks or islands or metros and still be able to provide the traditional services like L3 VPN internet or layer 2 VPN services. And I think that's one of the biggest advantages SRv6 brings, along with the scale of IPv6. Also, seamless integration in terms of any node, which essentially is not really SRv6 enabled node, but has the capability to do IPv6 routing, could potentially be used within the SRv6 to provide SRv6 core or transit services. You could also leverage 6P MPLS. You could potentially have SRv6 islands be connected through MPLS network. Application-aware routing, and I think this is very interesting, where you could do things like user constraints or application constraints can be programmed into the SRH. So that potentially can be done. All right, so this is just a snapshot of what we have seen. This is just a study which we have done across our customers, and what we have seen that APAC actually leads the pack when it comes to SRv6 due to some extensive deployments which have happened in this part of the region. Also due to the fact that APAC has been largely more IPv6 centric than other parts of the world. And also due to the fact that most of the scale which is required as far as consumers are concerned, services are concerned, obviously when we talk about A node Bs or access, largely it also depends on a population or a consumer base, which perhaps APAC is seeing more adoption in that sense. Overall, we see SR-MPLS being the flavor in Americas and EMEA, However, there is significant interest with SRv6 in other parts of the world too. So as far as industry standards are concerned, we have come a long way. I guess, SRv6 was the fastest adopted technology at ITF, even with all the controversies. So what's ready to consume? You have prefix summarization, flex algo, VPN, policy, OAM. And I think the most important part is the SRv6 MPLS interworking, which is very fundamental or critical to any technology transition. Also, multicast BRN6 has been adopted. And though we haven't seen a deployment, to be honest, but there are customers who are evaluating BRN6. Also, SRH compression has been adopted. CSID has been adopted. However, CSID also has two flavors. There is next CSID and replace CSID. Now, next CSID used to be known as microSID, and replace CSID used to be known as GSID. What's still cooking? Multicast, as I said, there is a lot of effort done at ITF to kind of come to a conclusion, which provides you an alternate to beer as a technology. So replication segment is one of the new drafts, which has been debated. SR-P2MP, BGP multicast, these are still work is being done to kind of make it more SRv6 compatible. There's also sensors and flows which are still being cooked in terms of there are a lot of sensors which are available. However, there is still a lot which we need to do in terms of tools. And analytics is a very big component when it comes to running a technology, right? So, and how does it connect to your operation tools? So I'll just go into the case study. So Axiata is a service provider, primarily mobile service provider in Indonesia. It operates in 5 regions, which perhaps is the entire country. And as you would be aware, Indonesia is a collection of perhaps 10,000 islands. So any technology transition is challenging. But XL's mandate was pretty straightforward. They had the intent to go with SRv6, and they had asked their vendors to align to that philosophy. What they wanted to do was simplify the routing stack. So they are a seamless MPLS provider based network. And they wanted to remove BGP, LU, RSVP, LDP, and just move with IGP, which is ISS with SRv6, have IPv6 control plane, data plane, and BGP as the control plane for services. So from a challenge perspective, obviously, it's a multi-vendor environment. It's a brownfield, very fragmented network. And most of the equipment actually lacked SRv6 capability, and they had 5G timelines, which they wanted to, perhaps achieve even with, such a big transition plan. And as far as approach is concerned, what we just went with a pragmatic approach of leveraging the existing install base as much as possible, coexistence of old and new platforms, as well as old MPLS-based network, along with the SRv6 new network. And interestingly, this network was just IPv4. So what we needed to do first was dual stack and use or enable SRv6 where possible and interwork with MPLS for services and business continuity. Also, one important aspect was that we wanted to focus on the network transformation first, and SDN later. So when I say SDN, it's a lot more than just the PCE controller. It also talks about automation tools, skills enablement, and how do you actually monetize some of the telemetry data to achieve application constraints. But the good thing is we actually deployed or in the process of deploying our SRv6 in the network. It's going to take some more time, obviously, looking at the geography, but it future-proofs their network for 5G expansion. Also, they are looking at future use cases like network slicing, edge compute, dynamic traffic engineering, low latency based services. So that just gives you a high-level transport architecture objective, what they want to achieve. So, for example, you have the network, which is a seamless-based network. We create multiple ISIS instance islands, which are SRv6 in nature, using Flex Algo as one of the choices for network slicing, and leak only the aggregates. So only the aggregates are leaked into each RAN island, which means that in the core, you only see a /40 IPv6 locator routes. Meanwhile, you also inject those routes back into another RAN instance. And that's what is required for any end-to-end packet flow from an enterprise customer or a home consumer or an eNode B to actually reach some of the centralized services, or perhaps to have an end-to-end service. And on this network, we potentially have traffic engineering policies because of the fact that there are constraints which they want to achieve in the core. So we try to match them with SRv6 traffic engineering along with Flex Algo. And overlay services are potentially unified in terms of EVPN providing all the kind of layer 2 services, and L3 VPN continuing to provide the existing L3 VPN services, MPLS VPN services. Perhaps another point is the whole automation piece is being built parallelly to the deployment. So as of now, these are things which are parallel in nature. We didn't want to be hijacked by the automation story. So we wanted the network transformation to happen in parallel. So key architecture enablers, as I said, one of the most important aspect is summarization. This kind of leads them to achieve their future scale, also scale for the next 10 to 15 years. The reason for that is obviously IPv6 and the way IPv6 has been architected in this particular network, that any island would inject only a /40 route into the core. The second aspect which is important is multi-instance ISIS. Now, this kind of complements the first statement, which is summarization. Multi-instance ISIS makes it much more simpler for us to inject the aggregate routes or to advertise aggregate routes into the various aggregation nodes, into the various aggregation nodes and vice versa into the core. The third most fundamental part is for any transition story, whether it's SR-MPLS or SRv6, you need to have business continuity for customers. And in case of SRv6, we do that providing MPLS to SRv6 interworking gateway, which essentially swaps the MPLS labels with SRv6 locator VPN sets. So essentially, the role for this particular internet gateway is to continue with existing services and the new services and make sure that the reachability for these spoke sites are still maintained. So there is no outage or a downtime for any of their customers. So now this is very interesting. When I say interesting, because this was something which was quite new. So as I said, there are 4 different vendors in Excel who are deploying SRv6. And to craft some locator design or locator addressing design, it took us perhaps 3 to 4 months. Now, that's the complex task. However, the good thing is it's done. When I say it's done, it's easy to replicate what we have done there. So, the reason for that was the scale of this particular network. the objective of this network for the next 5 to 7 years is to grow to somewhere around 50 to 60K. And for us to do that, we had to craft a design which provides a level of hierarchical aggregation. And if you see, we used ULA space, which essentially we split the locator space into core, IP backbone, and IP RAN, and then had individual regions and subrings to aggregate at each and every layer. So this kind of future-proofs the network for higher scale without revisiting the locator design. You have enough space to grow up to perhaps more than 100K or more, if we do hierarchical locator design. I'm not sure how I'm on time. Okay. So essentially, this is what we wanted to achieve. Going forward, each and every region or each and every island can grow immensely without perhaps pushing the state in the core. So each island basically sends in a /48 to the aggregation device, and which in turn aggregates it to a /40. Interestingly, this particular network today in BGP LU has around 30,000 routes. And in SRv6, we just have 11. So what we have done is amazing. We just moved all the IPv4 BGP LU based routes to just 11 in the core. And this brings me to the other aspect that once you simplify the network, once you scale up the network, you need to invest now in tools and skills to manage this particular transition of the network. Obviously, since last decade, people have invested in MPLS, so it's not going to be an easy transition. However, from a benefit perspective, this is what you get. So the core is just 400 gig, just focusing on the bandwidth rather than doing BGP LU at each and every hop. For benefit of time, let me just focus on this. This is logical network. These are not dual plane networks. These are logically split. So what we did was continue with IP MPLS in the core, but bringing new rings of SRv6 and have interworking gateway actually provide connectivity between the MPLS and the SRv6 islands, as I said. And as long as traffic proportion is close to 70% on these devices, 70% SRv6. Let me go back. Phase one, SRv6 just is 30% and MPLS is 70%. So we continue with MPLS in the core. As the traffic proportion actually changes, we decommission IP MPLS in the core but still have IP MPLS in the access because these are devices which still have life. So we need to kind of, have connectivity between the old and the new services. Considerations, 3. I would suggest and recommend anyone who's thinking of SRv6 to plan the locator addressing well in advance based on the vendors you have. And also, locators and infrastructure is different. So infrastructure should be GUA. SRv6 locators should always be ULA because of security aspects. It's a limited domain. I would recommend that you adopt ULA-based space. Services have standardized services. SRv6 SID structure requires sub TLV. However, some of the vendors have different ways to achieve that. So make sure that it aligns to IETF-based RFC 9252 and have SRv6 OAM standardized toolkit, which is working across all the platforms. Finally, interworking with MPLS, there can be no transition unless you have interworking with MPLS. This is just a recommended reading for skills enablement, and that's the end of my session. Again, just takeaways. Standards are evolving fast. Please join the standardization efforts at ITF. Interop testing is key if you have multi-vendor environments, and future use cases, you can have your own network slicing, edge compute, build your own use cases. Thanks. Thank you very much.
Thank you, Aditya. We're right on the 30 minutes. If you've got one question, maybe, anyone? One question, excellent. So remember, name and affiliation.
Hello, good morning. Mike from Globe Telecom. Yeah. The question is there a way to avoid the SRv6 and just continue with the SR-MPLS going to SR-MPLS version 6?
Absolutely. I don't think there's any reason for adopting SRv6. As I said, you need to see the objectives. You need to look at your scale. And if that is compatible with your SR-MPLS IPv6, that should be okay, I guess.
Thanks.
Thank you for your presentation today. This is a gift from the program committee and the organisers.
Thank you very much.
Great, good content, love it. Next up, we have Paresh. And apparently Paresh is searching for the Holy Grail on SRv6. So this should be very interesting. Hopefully you find it. Yes.
Thank you very much, Terry. Good morning, or is it afternoon? Okay, it's just ticked over. So good afternoon to all of you, and thanks to Aditya. I think he's made my life a little bit easier with the talk. A very balanced look at SRv6, SR-MPLS, and so on. So I want to continue along the same kind of vein. As Terry said, I'm going to talk about segment routing and the quest for the holy grail of transport protocols. And in particular, I'd be focusing on SRv6. So what I offer here is an opinion. It's my personal opinion. I am not representing my employer. So this does not necessarily represent their opinions. But I do hope to provoke a bit of thought out there about what we're doing in the industry, and particularly regarding SRv6. Where I stand right now, I see that there's potentially a bit of you could call irrational exuberance when it comes to implementing SRv6 out there. And I think the previous question that we had was actually quite on point. What are the motivations for deploying segment routing, and in particular SRv6? So that's what I'll be talking about. So I've already given the disclaimer. Okay, so why this fascination with SRv6, and why do we fall for the hype with any new technology, right? The Holy Grail, yeah, of course we'd like that. We would love to have this protocol suite that solves all our problems, that comes up with this unified architecture that solves the very significant challenges that we have in building transport networks, right? I think all of us would like that. So when someone comes to you and says, hey, I've got this thing that will do just that, it will solve all your problems. They tell you that we've managed to standardize this in record time. They tell you that there are hundreds of millions of subscribers on networks that are running this technology. They tell you that there are tens, hundreds of deployments already of this technology. They tell you that it's interoperable. Right? They tell you that it's going to bring order to the galaxy as far as transport protocols go. So you want to believe that because it's great. I think in the industry you want things that make things simpler, right? So we would like to believe that. But the reality is that there is no such holy grail. So I do not believe that there is a holy grail. Everything that we come up with, every technology has potential challenges to deployment and implementation that we need to think about. And that's really what I want to be talking about today. So I'll start off with a look at the hype around SRv6. And in fact, I would say that there's also a little bit of misinformation out there. I'm not saying it's deliberate, but that there are some beliefs that people have that may not be entirely accurate. So one is, that this is the ultimate transport protocol that will solve all of our challenges. And that, what I've heard from a lot of operators around the region is that, yeah, this is great, MPLS is great, SR-MPLS is great, but ultimately we want to get to SRv6. But I don't think that is not true. Right? It will not solve all our problems. They'll probably solve some problems, it create others, but largely SRv6 is doing what we can already do with SR-MPLS. There are some interesting elements of SRv6, like the Locator summarization that Aditya spoke about. Great. But, unless we have networks that grow to an order of magnitude larger than what we have today, the benefits may be somewhat limited because we're already doing it with SR-MPLS. Now, the other thing that I've heard is that SRv6 is absolutely necessary for building 5G transport networks. Now, what do you get from this? To me, when I hear that, it means that every single network that is carrying 5G traffic should have SRv6 or should be running on SRv6. That is simply not true. You could count on the fingers of one hand the number of scaled deployments of 5G transport networks that are using SRv6. And you still have fingers left over, right? So clearly that is not true either. We've heard lots of production deployments around the world. There are indeed some. It's not in the hundreds. A POC doesn't count as a production deployment. A field trial doesn't count as a production deployment. What we really want out of any technology in order to get confidence is a scaled deployment that's been out there for some time so that we've learned from what is happening. So that's not quite true either. Recently, I've heard from some people, some operators, that they've been advised that it's not possible to use SR-MPLS with an IPv6 underlay. Now, we just heard from Aditya that that's absolutely possible, right? So what that means is you can use SR-MPLS when using an IPv6 underlay. There's no issues with that. IPv6 has been around for what, 25 years? MPLS has been around for that long as well. So if you cannot do that, we've been doing something wrong. So that's absolutely not true either. Let me continue. Is SRv6 mature enough for large-scale deployments? No, I don't think you can conclude that. There are still some outstanding questions around SRv6, around compression, that we need to think about. We just don't have the production or the deployment experience yet to conclude that it is going to work in scale deployments without any issues. I'm not saying we will not get there. We certainly will over time, but are we there now? That's debatable. So where has all this hype come from? Has it come from operators? I don't think so. I think the hype has come from other avenues, and I'm sure you can work out where that is. So really, what I'd like to suggest here is that we've got to change turn the tables here. We've got to take an approach that is led more from requirements rather than the solution. Okay. So what I want you to think about is, if the answer is SRv6, what is the question? And have we actually asked ourselves this question? What is the question? So that's what I want to look at. Now, before I go there, just a few things about SRv6 that I should point out. Once again, referenced by Aditya already. So compression, right? In order to understand this, let me quickly describe how this works in SRv6, right? So the whole concept of segment routing is that we encode the path information in the header of the packet itself. So in an SR-MPLS variant of this, what we will be doing is having a label stack where every label in the stack indicates, you could say, an intermediate point in the network. So when we have a traffic engineered tunnel, you'd have a few of these, right? There could be SIDs, the segment identifiers for nodes, for adjacencies, and so on as part of that label stack. So we stick it in the MPLS label stack entry. Each entry is 4 bytes. So Okay, it's not a lot from an overhead perspective. Now, when we do SRv6, what we do is we try to emulate the same thing with SRv6. So you put a list of SIDs in an SRv6 packet. Now, there's no inherent way of doing it like we do with MPLS. So what we did is we developed this thing called the SRH, the segment routing header. And this routing header is where you carry the SRv6 SIDs. Now, each of these SIDs is 128 bits. So let me ask you a question. I mean, who thought that was going to be a good idea? To stick a bunch of 128-bit SIDs in the header of every IPv6 packet in order to achieve traffic engineering. Was that ever going to work? I mean, this is tremendous overhead that we're putting on the packets. And even if you didn't do that, if all you did no traffic engineering, just did the shortest path first routing, you would still need to encapsulate that packet within an IPv6 packet. So you're looking at 40 bytes of overhead, like, before you do anything else. Was this ever going to work? Right, so it's pretty clear that the basic premise, the very premise on which SRv6 was based was a bit flawed. So, operators started to raise some concerns about that. So the folks at IETF, they said, okay, you know what, this is a problem. Let's look at how we can compress this. So then we started looking at compression algorithms or technologies to address the problem of carrying all of these 128-bit SRv6 SIDs in the IPv6 header. So what happened then? Everyone came up with their own way of doing it. We had microSID, we had GSID, VSID, CRH, UID. I mean, there's probably others that I don't know of. But we came up with a lot of these mechanisms to do compression. And obviously, none of them were interoperable. So then what the IETF did was they said, okay, we've got to bring some order to this whole thing. So they set up this SRv6 design compression team. And the team was tasked with, firstly, trying to articulate the requirements of a compression technology. And then they took each of these compression technologies and said, hey, how does this compare against our requirements? So that we can work out what to actually standardize on. Now, at the same time, the proponents of the microSID and the GSID got together. They merged their ideas into a single draft, which has two different behaviors, the next CSID and the replace CSID. So essentially, the microSID and the GSID part of the same draft. So they came up with that draft. And as it turned out, the IETF decided that kind of meets all of these requirements that we're after. And that's good. We need some sort of consensus. The problem is that these two behaviors in that CSID are not mutually compatible. They do not interoperate. So you've got to use one or the other. So that's where we stand right now. The document is there. We've got two ways of implementing it. But who's going to make a call on what we implement? Can we afford to have two of these compression technologies, given that there is a potential dependency on hardware? So what's going to happen here? Is the market going to decide? Are we going to wait and see, hey, let's just sit back, see who adopts what? Do we go next CSID? Do we go replace CSID? That's not really a good position to be in, but that's where we are right now. So that's SRv6 compression. So we're not quite done yet. Now, the point I want to make here is that if we don't sort out compression, then we cannot really do SRv6 traffic engineering in a interoperable manner. So this is very important. You can do shortest path first, but TE requires a stack of these SIDs in the IPv6 header somehow. Security. Look, I mean, this is probably not the biggest issue, but it is something that I do here, right? When you look at a SRv6 frame, it actually looks identical to an IPv6 frame because it is an IPv6 frame. It's got an IPv6 source address. It's got an IPv6 destination address. So what SRv6 has done is it's kind of appropriated this mechanism to do a few things. Firstly, the locator part of it is great because it's showing simple IPv6. But then you look at things like network programming. We're overloading the concept of an IPv6 address with information around functions and arguments. So we're kind of blurring the lines there. With MPLS, that wasn't quite the case because MPLS labels do not have any intrinsic semantic to it. They were just a pointer to some other information. So when we did MPLS, it didn't really matter. We weren't overloading the meaning of a label. It would have the same kind of association with some other bit of data that you get once you look up the MPLS label. So it was quite different. The other thing is that when we had, or when we have MPLS networks, there's a clear boundary between the outside world and the MPLS network. Right? What comes into the edge of the MPLS network is some sort of native traffic, and you put an MPLS label on it. Right? It'll have a different ether type, and so on. So it's you can tell. I mean, you will not accept MPLS labeled packets from your customers, for example. Right? So that was very clear. With SRv6, it gets a little bit more complicated. And that's why we have those considerations that Aditya also mentioned about, whether you use ULA or not, and why that's a good idea. So we've got to think about those things. It complicates things a little bit more. So, to some extent, what we've been doing is, or what the industry, the market has been doing is, we've got this solution, we're looking for the problem. But I think we've got to change the discussion here and talk about what are the problems. For operators around here, that's a starting point. What do you want in your network? What are the problems we're trying to solve? Don't start with, hey, I want SRv6, how can we do it? That's a wrong question, right? So if you ask that question, the answer may or may not be SRv6. In fact, it may not be segment routing. I'm not beholden to segment routing either. Occam's razor, use the simplest possible technology in order to implement a solution that addresses your problems. That's what you've got to do. And I think that's how we've got to sort of have this argument in the industry out there. So again, I come back to the network requirements. What do we want out of the network? There's a few that I see out there. High scale traffic engineering, right? We've operated traffic engineered MPLS networks for 20 odd years now. There are challenges, absolutely, with scaling MPLS, particularly RSUPTE. We know that. And we're now in an environment where what we want is more granular traffic engineering, potentially even flow-based. We want on-demand instantiation of these traffic engineered tunnels. So that's one requirement that we need to somehow meet. We are after SDN-based control. We know that there are tremendous benefits of being able to make decisions at a centralized point in your network. So you need to have some sort of solution that enables that gives you this centralized topology view of the network that is able to look at the network as a whole and make decisions that get better outcomes through the network. We have to do all of this while reducing the state in the network core. Once again, a problem with protocols like RSUPTE, with the amount of signaling, the amount of state, and so on. We have to address that. We have to simplify protocols. Way too many protocols. We like doing that as engineers. We keep, you get a new problem, new protocol. Come on, can we rationalize some of this? We also want IPv6 support, right? This is important. So this is not negating the fact that the world is moving to IPv6 infrastructure. Now, a lot of operators around the world are still using IPv4 in the underlay, right? There aren't many operators doing IPv6. There may be some doing dual stack, but IPv6 only infrastructure, not that many operators, because we haven't had that crunch in that part of the network in order to move to an IPv6 infrastructure. But we got to get there. So we have to support this. We need to have technology confidence, right? Before you go out and rip out all of your existing nodes and so on so that you can put on this shiny new technology, there's got to be a good reason. You've got to be fairly confident that this is going to work, and it's going to work in an interoperable manner. What you do not want to do is lock yourself into a proprietary solution, and hence, you have issues with that in the future. And you want a mature standard space. You definitely do. Now here, we know that it takes a while. It takes a while for standards to mature. Now, you can never say we're done when it comes to a certain standard. So you will have to draw the line somewhere, but you want to have reasonable confidence that what you're implementing is mature enough. Now, from a service perspective, you want to support all the 5G use cases. 5G brings with it three key categories of use cases around enhanced mobile broadband. There's massive machine type communication, which is IoT. There's something we call UR-LLC, or ultra reliable low latency communication. So they all have different requirements. You want to be able to support those kinds of services. You want to support enterprise IoT services. You want to support cloud use cases, right? So very on-demand instantiation of connectivity with SLA guarantees that go with it as well. You want to support things like service chaining. Well, the data center has to be a part of your network connectivity to be able to do more with that traffic. So this is where segment routing came in, right? So the whole concept of segment routing was to use a source-based routing paradigm. So what we do is we have this capability to explicitly specify the path any particular packet takes through the network. And we do it in such a way that it does not require state in the network on a per tunnel basis. The way you're able to do this is by putting that path information into the packet header, as I mentioned earlier. So every single packet has that information in the packet itself that helps the network to direct it around the network. And what we did with segment routing is we extended the IGP so that the SID information, the MPLS information, even the SRv6 information is carried in the IGP. So it makes it easier to introduce it into the network. It's an extension to a protocol as opposed to a new protocol itself. So it made a lot of sense. And in this network, the state is kept on the ingress router. So the basic concept of segment routing is the same, whether you use SRv6 or SR-MPLS. You're achieving the same thing. You just have to achieving via two different means. There are some benefits that SRv6 brings that SR-MPLS doesn't, and vice versa as well. So, if you then take these requirements and map it against the two technologies, then at this point in time, the way I see it, there are some challenges with SRv6, so around compression and so on, right? Both of them support high-scale traffic engineering. That's not an issue. The issue comes around the fact that while the MPLS data plane for SR-MPLS requires no change to your forwarding architecture, you can use existing chipsets. The SRv6 forwarding plane does require change. There is a hardware dependency. So, generally when we try to build new protocols, we want them to be backwards compatible. This is not quite backwards compatible because it needs you to potentially upgrade your hardware. So you saw how we have a requirement to interwork between SRv6 and SR-MPLS. So that becomes a barrier. And before you take this plunge, you have to think about that. What am I getting? If I have to upgrade my hardware, I better be getting something really good for it. The reduced state in network core, both variants do that. Protocol simplification, both variants do that. SDN-based control, pretty immature for SRv6, right? If you look at the controllers and the capabilities, there are still some issues being worked out around PCE and the different types of compression mechanisms. SR-MPLS is definitely more mature. There are many large production scale deployments out there. IPv6 support, they both support it. It's not one or the other, they both support IPv6. 5G use case support, right? Subject to the other limitations, they're supported on both of them. It's just that, SRv6 is a little bit immature. It's catching up. They all support the enterprise use cases, the cloud use cases, service chaining capabilities. When it comes to technology confidence, though, once again, it's SR-MPLS is ahead of SRv6 at this point in time, more mature. The migration to SRv6 can be complex. Like I said, a lot of operators are running an IPv4 underlay. Just moving to an IPv6 underlay and with IPv6 control plane, without even thinking about SRv6, is a complex undertaking for anyone who's actually ever done it. So, it cannot be understated how complex that is. And that is a necessary prerequisite before we can implement SRv6. So we've got to think about that. The hardware ecosystem, like I said, a lot of existing networks, brownfield networks will not support SRv6 without hardware upgrades. So we have to think about that. How easy is this to deploy in the network? Do you go with SR-MPLS or do you wait for obsolescence and give up on any of the benefits you can get with SR-MPLS? So these are decisions that operators have to make. So, okay, so looking at segment routing, it seems like a pretty good fit for addressing a lot of these next-gen transport network requirements. It meets quite a few of these requirements. So the question back to you is, what do you want out of your transport network? Start from there, work out what you want. The solution may be segment routing, it may not be, and that's fine. You know, like I said, the point is you find something that works for you. I personally think, you know, there is definitely good in SRv6. So I'm not negative on SRv6, but what I'm saying is that we've got to take a cautious approach here. Over time, we'll fix up the issues. Compression will get sorted out. You know, the interoperability between operators, between vendors and equipment will get sorted out. Well, we're not quite there yet. And so we should take a more conservative, cautious approach to deploying this in your network. And that brings me to the end of the presentation. I'm done here, Terry. Yes, thank you.
Well, in that case, we have plenty of time for questions. So if we have anything from the audience or from Zoom, that'd be good. But from me, you haven't found the Holy Grail yet.
Oh, I'm still looking.
So a question from the Zoom chat from Drew Roddy. You don't mention network programming in SRv6 RFC 8986. Thoughts or useful or hype as per you?
No, I think it's a good question, Drew. And yeah, I didn't quite mention that. I think there's definitely value in network programming. And I also see that there's value in having a single data plane that exists in or extends into your data center as well. So absolutely, I think there's value in that. But then we've also got the MPLS network actions, right? So that's coming up as well. So you can achieve that in MPLS as well. So that's my view on that.
Thank you.
So any further questions? Well, that's good. I think they're all waiting for things to happen later on. Okay, thank you, Paresh. Everyone, a round of applause for Paresh. So next up we have Takashi-san. And refresh me, your topic is?
Thank you, Teresa. I'm Takeshi Sensei from SoftBank. SoftBank is an operator, mobile operator. And I will talk about how to implement SRv6 on our mobile network from the operator's point of view. I will introduce myself and then I will talk about why we chose SRv6 and some challenges during implementation. Lastly, I'd like to share our next challenge regarding SRv6. I had worked as an internet peering coordinator for 14 years in SoftBank, and we have expanded our network internationally as our network grew larger. And now I'm responsible for planning mobile backhaul. First, I will talk about why we chose SRv6 for our network. We have adapted our network for the mobile generations. We have selected the fastest interface speed and the most efficient network topology each time. During the third generation, we had 1 gig interfaces and our network was operated by OSPF and BGP. For the fourth generation, we enabled MPLS and upgraded the bandwidth. Currently, we have adapted SRv6 for the fifth generation mobile system. And we have expanded the new 100 gig network and have been migrating from the old network. And we are using 400 gig interfaces partially in our network. There are three popular requirements for the 5G network. They are really simple, but not enough when planning a new network. When we plan a new network, we usually collect the information of detailed requirements from operator team, like the marketing team and radio access team and other teams. It's a tough work, but possible. Of course, network engineers also have a lot of ideas which can solve confronting issues. In my opinion, it's the most exciting work for network engineers. Why do we build a network? I think we built a network for making use of applications. But we usually do not have definite requirements when we are planning a new network. Looking back on the previous generations, bandwidth improvement has always come first. After that, some applications that make use of those features came up. I can imagine that new applications that make use of the three major requirements of 5G will come up in the near future. It's best that we can foresee the new applications while considering a new network, but we cannot. Moreover, since we will have changes in mobile system generation every decade, we have to manage our network and keep providing new functions that are tailored for new applications constantly for 10 years. I think SRv6 is not completely mature, but it is also that SRv6 has much possibility. We are not making full use of network programmability now. But I believe that we can tailor network programmability for yet to be seen applications and services, like this slide in the future. There are many discussions about why we are running SRv6, even in SoftBank. But my understanding is that we choose SRv6 for its potential. Next, I will talk about challenges that we were facing during SRv6 implementation. We had to install new devices for 5G as soon as possible, especially SRv6, since new functions have been implemented in succession. We had to upgrade the software several times while installing. In addition, we also had to deal with bugs. It's not so hard and rather ideal to migrate an old network after completing a new network. But the process is not fast enough. We had to build a new network and migrate an old network simultaneously. We used to use Perl and Python scripts to automate work, but not all engineers were familiar with scripts. I think it was one of the problems about automation. In-house tool called Autoran helps improve our network operation. Autoran has some features, and I think the best point is that network engineers can make requests to the developing team directly. And its developing speed is faster than other tools. As a result, we could finish upgrading the software with no accident. We have some remaining challenges. One is fully automated. We have to trigger the tool now. We plan to try unattended operation. It's really important to avoid the downtime, even in accidents, as the mobile network became the critical infrastructure. We are operating SRv6 with multiple vendors, and we have found the interoperability issues. I will share two examples. First, under the layer 3 VPN configuration, the function lengths of sheets were different between vendors. I could not say which is right, because I could not find a specific number for the function length in RSC. Anyway, we had to ask them to keep interoperability. The second example is about the MTID of ISIS. Since some routers could handle only MTID 0, it is impossible to add such a router in MTID 2 configuration. I could not find any definition in RFC, and it depends on vendors' implementations. SRv6 is a new technology, and I think these issues cannot be helped. From the operator's point of view, we have to test enough before implementing in a commercial network. Actually, we found these issues in the lab. Finally, I will introduce our new challenges. We are running SRv6 on our network, but as you know, SR-MPLS covers most of SRv6 features. SRv6 mobile user plane needs SRv6. I think it's the initial use case for SRv6. Smartphones have to terminate at 5G core network, but SRv6 MUP offers connectivity without 5G core network. We can offer SRv6 MUP for delay-sensitive application. Our development status about SRv6 MUP, we have started a trial on our commercial network since last month. There were a lot of challenges. For example, it was the first time we used white box switches and cooperated with the IP network team and the mobile core team. We have a lot of works to improve redundancy and quality to provide it for our customers. We continue to improve our network that is suited for yet to be seen applications and services. This is all for my presentation. Thank you for listening.
So, do we have any questions? We've actually got about...
So could you speak slowly so that I'm not good at English?
Sure. Thanks for an excellent presentation. So I had a question about compression. Has that been deployed in SoftBank?
Not yet. Not yet. We are just discussing about compression.
Okay, thanks. My name is Aditya.
Yeah.
So, Wal, did you have any from Zoom? No. No, I'm intrigued too. SoftBank being a mobile operator, your applications obviously include voice. Are you transitioning to voice over IPv6 to run natively on your network?
Yes.
So I think if we have no more questions, we will be able to give you approximately 8 minutes back in your day, if that's okay. Of course, if our other panelists today, if you want to catch up with them during the lunch break, I recommend doing so. But Takashi-san, thank you very much.
Thank you. Thank you.
heart, we try to be each other's light. Oh, may no lies be denied. Let our children smile. You're not alone. Link your heart to mine to be each other's light. Don't you give up. No, 어떤 어려움도 이겨낼 수 있어. We'll be on your side forever.